You have learned a lot about writing queries. You have seen that these queries can sometimes get complex, especially when we use multiple joins and subqueries. This is where views come to the rescue. We can save these queries or subqueries in a view, and this will greatly simplify our select statements. And then we can reuse these views so we don't have to code those queries again. Let me show you. So in our SQL invoicing database, I'm going to write a query to get the total sales for each client. So let's select everything from the clients table and join it with the invoices table using the client ID column. Now I'm going to pick a few columns. So c.clientID and c.name. And then finally, let's calculate the sum of invoice total for each client and call it total sales. And then we need to group by client ID and name. Let's execute this query. There you go. So we see the total sales for each client. Beautiful. So this is a very useful query. In the future, we might have a lot of queries that will be based on this query. For example, we may want to get the list of our top clients or the clients with the least sales. Now, instead of writing this select statement every time and changing it slightly for each query, we can save this query in a view and reuse that view in many places. Let me show you. So before this select statement, I'm going to write create view. Let's give our view a name like sales by client. And then we type as. So right after as, we have our select statement. Now let's execute this statement. Now we don't see the result because here we're executing the create view statement. So this statement doesn't return result like the select statement, right? Instead, it creates a view object. Let me show you. So here in the navigator panel, in our SQL invoicing database, we need to expand the views folder. But first, let's refresh this view. All right. Now let's take a look inside the views folder. There you go. This is our new view, sales by client. Now, just like a table, we can select the data from this view. So here's the result of our view, but we can also use this view just like a table. For example, we can select everything from sales by client. Now we get the same result. We can order the result by total sales in descending order. Now we can see the top client, that is client number 5. There's so many different things we can do with this view. We can apply a filter here. So where total sales is greater than, let's say, $500. Now, one of our clients disappeared. We can also join this with any tables that has the client ID column. For example, we can join this with the clients table using the client ID column. Now we see all these attributes about each client, their ID, their name, their total sales, their address, their city, and so on. So views are extremely powerful and they can greatly simplify our future queries. Anytime we need to deal with sales by clients, we can reuse our view. We don't have to write this query, this select statement from scratch. So a view behaves like a virtual table, but remember, views don't store data. Our data is actually stored in our tables. A view just provides a view to the underlying tables. That is why we call them views. All right, now for your exercise, I want you to create a view to see the balance for each client. Call this view client's balance. And in this view, we should have these columns, client ID, name, and balance. We calculate balance by subtracting the payment total from the invoice total in invoices table. So the balance is the difference between what we charge each client and how much they have paid us. All right, I'm going to select everything from the clients table and join it with the invoices table using the client ID column. Now, I want to pick a few columns, c.clientID and c.name, and then we need to calculate the balance. That is the difference between invoice total and payment total. Let's call this balance. Well, let's execute this query. All right, this is what we get. So for each invoice, we see the client ID as well as the balance. Now we need to group this data by clients. So technically here, we need to calculate the sum of invoice total minus payment total. And then we need to group our data by client ID, and name. Let's execute the query again. There you go. So we see the balance for each client. Now let's put this query in a view. So on the top, we write create view clients underline balance as, there you go. Let's execute it one more time. Now back to the navigator panel. I'm going to refresh this view. Here we have this new view, client's balance. We can see all the data in this view. Beautiful. Once you create a view, you may realize that your query had a problem. So you need to go back and change your view. In this tutorial, I'm going to show you two ways to do this. One way is to drop the view and then recreate it. So we can type drop view sales by client. We could also write this in the same query window. It doesn't matter. Let's execute this. Now our view is gone. We can go back to our first query window and execute this statement one more time. So this is one way to recreate the view. The other way is to use the replace keyword. So we can change this create view statement like this, create or replace view. And this is the preferred way because you don't have to explicitly drop a view first. Now we can execute this statement as many times as you want. Now, what if this query window is gone and you don't have access to the query behind this view? Well, a lot of people save their views in SQL files and put these files under source control. It's a very common practice to check these files into a Git repository and then share that repository with other people so everyone can recreate this database on their machine. That's a really good practice. So here we can save this file in a folder called views. And in this folder, we're going to have a file with the same name as the view. That is sales by client. Then we can put that folder under source control. So this is one way. But in case you don't use this in your organization, you can always come back here and click this middle icon. This opens the view in the edit mode, but you can see a bunch of other stuff here that we didn't explicitly code. MySQL added these. Like, quite honestly, I'm not sure why MySQL does this, but one thing you need to know is that MySQL surrounds your table and column names with this backtick character. And this is to prevent a name clash. So if you use certain keywords that have special meanings in SQL, MySQL would treat those just as table or view or column names. Obviously, this makes your code a little bit convoluted, but that's something you have to deal with. So let's make a small change here. I'm going to add an order by clause, an order by total sales in descending order. When we're done, we need to click the apply button. It's on the bottom right corner of the screen, but unfortunately, it's not visible in my recording window. It's right here. So click apply, and then MySQL generates a SQL statement like this, create or replace, blah, blah, blah. And here we can see the change that we applied. So once again, we apply, done. But obviously, this is not the ideal way to update views. As I told you before, as a best practice, you should save your views in SQL files and put them under source control. So far, you have seen that we can use our views in select statements, just like our views, but we can also use them in insert, update, and delete statements, but only under certain circumstances. If the view doesn't have the distinct keyword and any aggregate functions like min, max, sum, whatever, group by, or having clauses, and these basically go together because most of the time when we use an aggregate function, we often have a group by clause as well. And finally, the union operator. So if we don't have any of this stuff in our view, then we refer to that view as an updatable view, which means we can update data through it. So we can use that view in insert, update, or delete statements. Let me show you. First, let's have a quick look at our invoices table. Here we have these two columns, invoice total and payment total, but we don't have a column for the balance. So every time we need to work with the balance, we have to calculate it. We have to subtract the payment total from the invoice total. Now we can create a view for our invoices table that includes the balance for each invoice. So let's create or replace a view called invoices with balance. And here we need to write select. What columns do we have in the invoices table? Invoice ID, number, client. Let's add these. Invoice ID, number, client ID. Next, we have invoice total and payment total. We need to add these as well. So invoice total and payment total. And finally, 3 more columns: invoice date, due date, and payment date. Let's add these as well. Invoice date, due date, and finally payment date. We select these from the invoices table. So we have selected all the columns in this table. Now we want to add an extra column here. That is invoice total minus payment total, and we call it balance. Now let's also apply a filter here and only return the invoices that do have a balance. So balance should be greater than 0, where invoice total minus payment total is greater than 0. Unfortunately, here we cannot use the balance alias. If we do this, MySQL is going to say there is no column called balance. So we'll have to rewrite this expression here. Okay. Now let's execute this statement. Beautiful. So we should have a new view. First, let's refresh this view. All right. Now under views, we have invoices with balance. So in this view, we have the invoice total, payment total, and the balance for each invoice. Beautiful. So here's the code for this view. Here we're not using the distinct keyword. We're not using any aggregate functions or group by. Neither are we using the union operator. So this is an updatable view, and we can use it to modify our data. So I can open up a new query editor and delete from invoices with balance where invoice ID equals to 1. So we can delete records from this view just like a regular table. Let's go ahead. Our invoice is deleted. Now back to this view. Let's refresh the result. We no longer have the invoice with ID 1. We can also update an invoice. So let's push the due date for invoice number 2 to 2 days after. Here we use update. We want to set the due date to 2 days after. How do we do this? In the last section, you learned that we can use the date add function to add a date part to a datetime value. So here we pass the current due date, and then as the second argument, we write this expression, interval to day. Now with this, we can update the due date for invoice number 2. Beautiful. So back to our view. Currently, the due date for this invoice is July 1st. When we refresh this view, it's going to be July 3rd. There you go. It's July 3rd. We can also insert a new invoice through this view, but this one is a little bit tricky because this will only work if the view has all the required columns in the underlying table. For example, if we didn't have this invoice date column in our view, we couldn't insert any rows through this view because our table cannot accept null values for the insert date column. Okay. So to recap, most of the time we update data through our tables, but there are times that you may not have direct permission to a table for security reasons. So your only option is to modify data through a view. In those cases, you can use your views to insert, update, or delete data, assuming that your views are updatable. We'll look at security and permissions later in the course. In the last lecture, you learned about the updatable views. Now, following the same example from the last lecture, let's see what happens when we update the payment total for one of these invoices. So here we have invoice 2. The payment total is less than the invoice total. We have a balance, and that is the reason we have this invoice in this view. Now I'm going to update this invoice through this view and set the payment total to the exact same amount as invoice total. So the balance is going to be 0. What do you think will happen? Let's take a look. So back to our query window, I'm going to update the invoices with balance view and set the payment total to the invoice total for invoice number 2. Let's execute this statement. All right. Now back to our view. Let's refresh the view and see what happens. Invoice number 2 disappeared. So this is the default behavior of views. So when you update or delete data through a view, some of the rows may disappear. Now there are times that you want to prevent this. You don't want an update or delete statement to exclude a row from the view. Let me show you how to do this. Back to the code for this view. At the very end, after our select statement, we type with check option. When we apply this clause, this view will prevent, update, or delete statements from excluding rows from the view. Let me show you. So I'm going to recreate this view by executing the statement. All right. Now, let's go back to our view. Let's update another invoice, invoice number 3. Here we don't have a payment. So back to our query window. Let's set payment total to invoice total for invoice number 3. Now, when we execute this statement, we get an error. If you look at the output window, you will see an error like check option failed. So by default, when you update data through a view, the modified rows may no longer be included in the view. You can use the with check option clause to prevent this. So if you try to modify a row in such a way that it would no longer be included in the view, you will get an error. As you have seen, views can help us simplify our queries. But there are a couple more benefits to using views that I want to briefly talk about. The second benefit is that views can reduce the impact of changes to your database design. What do I mean by that? Well, imagine you have 10 queries written on top of the invoices table. Tomorrow, you decide to make a change in this table. You may decide to rename the table or one of its columns, or you may even decide to move one of the columns in this table to a different table. What will happen to your queries? You'll have to come back and fix all those queries that reference this table. Now, what if I told you that you are not allowed to write any queries against this table? Instead, you should always use this view that we created earlier, invoices with balance. This view looks almost exactly like our invoices table, but it has one extra column, the balance, which is also very useful. Now, if we decide to make any changes to the underlying table, that is the invoices table, we can simply modify our view code and use an alias for the changed columns to bring back their old name. Or if we move one of these columns to a different table, we can join the invoices table with that table and bring back that column. With this design, the only place we need to change is the view. If all our queries are based on this view, they will not be affected by a change in the underlying table, the invoices table. So, views provide an abstraction over our database tables, and this abstraction reduces the impact of changes. There is also another benefit to using views. We can use views to restrict access to the data in the underlying table. For example, in your view, you may use a where clause to filter the records, or you may exclude some of the columns in the underlying table. If you remove direct access to the table, users can only update data through your views, and they won't be able to modify the value of a certain column or modify the rows that are not returned by your view. Of course, this is not always that easy, and it requires a lot of planning. Otherwise, you will end up with a big mess. So, be aware of these benefits, but don't apply them blindly to every situation. Just remember that views can help you simplify your queries, so that's a great winner. But also remember that you can use them to put an abstraction layer over your tables and reduce the impact of changes. And finally, you can use them for data security. All right, we have reached the end of this section. In the next section, I'm going to talk about stored procedures and functions.